Now, you spent almost a decade or more than a decade in AxoSim or now 28 Bio. It's interesting to talk to you because you have basically created a company from science to commercialization stage to the point where you were talking to 20 large pharmaceutical companies to adopt this technology. I think our audience would love to hear that story of how you bring the technology from the lab all the way to start talking about serious players in the field.
Yeah, absolutely. It was quite a journey, still is, I would say. But to take a step back of why I got in the field, and I'll say to build a company and to do all that takes a lot of work, takes a lot of effort. You really put yourself out there. And I dedicated myself doing this because I actually had a neurological issue myself. So in college, I had a seizure. Uh, it was out of nowhere, no family history, no warning. And ultimately, I was diagnosed with what's called an AVM. It's an arteriovenal malformation. So essentially, in one part of my brain, the arteries and the veins were so tangled up that blood flow got trapped in there. I'd had it my whole life, but for whatever reason, this one day, the pressure got so high that it caused a seizure. And you can imagine that that was quite a life-changing moment. And it just really had me start digging in and realizing we just don't know much at all about the brain. The surgery I ended up having was just radiation. So they shrunk this thing so small that blood wouldn't go into it anymore. So they didn't cure it. They didn't know what to do. They fixed it, right? I'm okay. But that drove me to really question, how do we learn more about the brain? How do we make sure we get treatments out there to solve issues much worse than that? And that's what led me to the field of tissue engineering, being able to build models. This was before, frankly, NAMS and MPS. This was in 2007. I realized I could build models of the nervous system and start to really look at regenerative medicine. How does it react to injury? And I worked with a PhD advisor, and we were able to develop our initial technology, which is called a nerve on a chip. And that was the start of the scientific basis for it. As I mentioned, originally it was for regenerative medicine. So we were actually looking at if you have an injury to a nerve in your arm, for instance, it doesn't grow back. So how can we perhaps figure out some biomaterials to put in to allow that nerve to reconnect? Well, once we developed that technology to a certain point, pharmaceutical companies started coming to us and saying, well, that's really interesting for an injury model, but what if we tested drugs on that? What if we used that to look at, for instance, a lot of cancer oncology drugs cause damage to the peripheral nervous system. So they can cause chronic pain in your arms, loss of use of your feet. We basically heard them, right? And I was crazy enough to say, hey, what if we do this as a company? And so what we went out and did, my professor along with me, was we talked to dozens and dozens of pharmaceutical scientists and said, hey, what are the problems you have? Essentially customer discovery. It's something that's really popular now. And we realized we had a product and there was a market for it. So we had this fit. And in 2004, we basically said, okay, let's take the plunge. We're convinced there's something here. I'm convinced it can make a difference. And we started the company.
But it seems like the decade long of the company building, there are quite a few milestones. First, you developed in-house technologies, but you also use the strategy of licensing, merger and acquisition strategies to grow the portfolio. Why don't you tell us a little bit about that?
Yeah, no, absolutely. So obviously that was the genesis in 2014. And we originally built the company off of federal funding. So Small Business Innovation Research grants, STTRs, technology transfer grants. And so we were able to basically get the money, specifically to commercialize these technologies to start. And so what we did there was we started testing drugs in this model to be able to start to say, we are more accurate than animals, right? We've tested all these drugs. We accurately said what was going to happen in humans. So that was the beginning of the company. And being in neuroscience, I told you that 94% failure rate. We realized we could grow beyond just this safety toxicity question to start modeling different diseases. And as first-time entrepreneurs, we kind of thought we have this platform, it can do everything, right? Let's build it to do multiple sclerosis. Let's build it to do ALS. And we realized you have to be realistic about your technology, know the weaknesses, know the strengths, right? And so we said, okay, we want to be the organ on a chip company in neuroscience. How do we do that?